Welcome to the practicals, as it were. So far, we've had 4 videos. Theoretical whiteboard stuff, talking about neural network structuring, doing gradient descent, backpropagation, doing a bunch of calculus. Then too much, no? What is the second PUC or what? So in this video, let's write some code, a very simple project. The example that we've been doing for the entire series so far, show the neural network a digit and it recognizes that digit without you helping it. But first, I've got to make some tea. I need my chai. It's like almost noon and I haven't had my morning chai, so 1 second. So this project is actually quite simple thanks to abstraction. We're going to use Tensorflow, which is a machine learning library that was created by Google engineers for themselves. And in 2015, they said it's okay, we'll make it open source so anyone can use it.
कभी-कभी लगता है कि अपन ही भगवान है.
We'll also use Keras, which is a neural networks library that works on top of TensorFlow. So TensorFlow and Keras working together help us abstract the process, make it a lot simpler. So for example, if you have your input and the output layer of your neural network and you want 3 hidden layers or 2 hidden layers, you just specify that and it's taken care of. And in your neural network, you also need an activation function. Which one do you want it to be? A step function, sigmoid function, activation, ReLU activation function. You just specify it. You don't have to sit and say, oh, I want sigmoid activation function, so I have to do the underneath calculus 1 by 1 plus e to the power nothing. You just specify it and it's abstracted, it's taken care of, which is perfect for someone like me, someone else doing the heavy lifting and me sitting and chilling, drinking my chai. And finally, for the actual training, we're going to use the MNIST dataset, which consists of 100,000 photos of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 written in different styles for our neural network to learn from. Okay, so here we are in Visual Studio Code. I've just opened up an empty Python file, neural network test.py. And the first thing we need is, as I said, import some packages. So first thing, TensorFlow for the library. So import TensorFlow as TF, right? Then we need NumPy to do some data manipulation. You'll find out how it goes. So import NumPy as NP, and we also need matplotlib just to display what we've done. So show the results, etc. So import matplotlib.pyplot as plt, right? And import OS. I don't think we need OS. Screw it. So we've got the packages now. We have to get our data set as well, the MNIST data set. So MNIST equals tf.keras.datasets.mnist, get it, and then unpack it. So unpacking is like opening up the box, seeing what ingredients are there, that kind of thing. So we need to train, we need parameters to train, we need parameters to test. So we're going to do xtrain. We're going to unpack it into xtrain, ytrain, xtest, ytest equals what do you do? MNIST dot load data. So we're loading the data. We got the MNIST data and unpacking it into xtrain, ytrain, xtest, ytest. And I hope I've got the data here. And just to check, print xtrain the 0th index, and this hopefully should show us the matrix of whatever data is in the 0th index of that 0th image. So here, right, this is the image at the first position in the MNIST dataset, and these are its activation values. So it goes from 0 to 255, but we don't actually want this activation function to go from 0 to 255 as we've discussed in the previous videos. For neural network activation, we keep it 0 to 1, some level of activation between 0 and 1. So we'll use the normalize function to normalize this value from the range of 0 to 255, bring it down to 0 to 1, which is what I've written here for the train and the test, tf.keras.utils.normalize. And if we take our print function, statement from there to here, and you print it now, hopefully all of this value here that is 0 to 55, should become 0 to 1, some value between 0 and 1. Plus, 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 do something. Why? Oh, I see it. I thought it didn't do it. It's just done it again. So as you see here, 0, some value between 0 and 1. Perfect. Okay, so let's minimize this, get rid of that print statement. And so far what we've done is we've prepared the data, right? So data prep phase, and now we will define the model, the actual neural network that works. So model equals tf.keras. By the way, all of this this syntax tf.keras, all of that I don't remember. I just consult the TensorFlow library. So tf.keras.models.sequential. This is a general sequential model. One feed forward, go from this layer to that layer to that layer. That's how it works. So model defined. Now we have to flatten the model, because input is a bunch of pixels, right? And some matrix, this into this, the x into y matrix. We have to make it into one input layer, right? If you remember from the theory. So for that we use the model.add tf.keras.layers.flatten, right? This flattens it into one input layer. Then we put our hidden layers. Let's say I want one hidden layer. I don't know if that's enough, but we'll see tf.keras.layers.dense is a hidden layer. And how many neurons do you want? Let's say 64 neurons in this layer, and I want to give it an activation function. So activation is tf.nn.relu. We'll use the relu activation function. Let's say we want 2 hidden layers just for the aesthetics of it. So these are 2 hidden layers. So we flattened it first. So that's one input layer. Then 64 neurons each, 2 hidden layers. Then we'll do it again, but this time it's not 64, it's 10, because this is the output layer, and the output layer has 10. So it's 0 to 9, 10 neurons in the output. And ReLU is not suitable for giving you an answer at the output for this kind of application. So let's use softmax instead. So that's our network, that's our neural network that we built here. Okay, so model is now ready. We have to, well, it's not ready. We have to compile the model, give it some metrics for it to work with. So model.compile, first we give it an optimizer, right? So optimizer, we'll use the Adam optimizer because everyone uses Adam optimizer apparently, right? And then we have to specify a loss function for it. And what I've read is sparse categorical cross entropy is what is best. And then we have to specify metrics, right, for it to track the metrics. So metrics for us is just accuracy. Can I spell please? Right, accuracy. Okay, now we have compiled it. Finally tell it what to do, right? So we'll tell the model what to do. Model.fit, what do you want me to use? X train and Y train, right, for training, and use epochs equals, how many epochs do you want? 3 epochs, 2 epochs. Epoch is like a training cycle. So if I say 2 epochs, it will go through 2 training cycles. And also what we'll do is model.evaluate, because testing is one, and then training is one and testing is one. So for testing, evaluate x test and y test as well, x test, y test, and unpack that into, I'll just do it here, val loss, val accuracy, validation, and just for us print that out, val loss, and print out val accuracy as well. Okay, so we have everything ready with the model. I just saved it with model.save and then opened it again with our model, because now our model has everything that we parameterized here. I just saved it because we don't have to lose all this parameterization again. So we can finally hopefully make our prediction with prediction equals our model dot predict show me what's in the test data, right? And to get the answer, we will just print out the answer. This will be our output, right? So we'll use numpy np.argmax of what's in the prediction, and let's say what's in the prediction of the 3 index in that, right? So this will be the output answer. Output the answer, like I mean what the neural network thinks it is being shown. And finally, for us to show our work as well, to compare, we'll put out the input as well, right? So we'll use plt in matplotlib, plt.imshow what is in xtest at 3. So 3, yeah. So this is the input that the NN is seeing. So this will be displayed as a photo, and then the print statement will show what the actual answer is, right?
One eternity later.
Okay, so finally I was about to show you the result. Did all of this, result wasn't coming, and it was saying plt.mshow syntax error. I was like, what syntax error? plt.mshow only. I thought matplotlib was not installed correctly, so I reinstalled it, reinstalled numpy, reinstalled tensorflow, nothing was happening. So I was like, I spoke so much about this code, and then its result is not coming. So I debugged for like 20 minutes, seeing what is happening. Finally, it is this print statement at the end of this one bracket wasn't there. So I had closed this argmax bracket, but the entire NP I didn't close. So it was saying plt.mshow is error. Oh, wow. So finally it is working. I tried it. Now if it screws me, so what should happen now, hopefully, is when I run this code, it should go through the epochs, because we've given 2 epochs here, the training cycles, go through them and tell me what is my accuracy, how much model accuracy we've got, what is it, validation loss, everything. Show me the input, what the input is in the 3 index, and show me the output. Okay, please, please, please. You've done it now before I start recording, please. So see, one epoch is done, 83%, 95%. Show me the, see, okay, yes. So 0 is what we were showing it, and that is the input, and the answer right here is 0. If you just want to check, if you want to do it again, we put the 4th index just to check what's in the 4th index, because 0 was in the 3rd index, and we got the correct answer. Now hopefully run 2 epochs and give me what's in 4. Running, 83, 84, 95. We have answer 4, and the input was 4. So that was pretty much it. We showed our neural network 100,000 oh, my leg was up. We showed it 100,000 images of written digits 0 to 9, and it learned by itself. I mean, thanks to abstraction from TensorFlow and Keras, we trained it to learn by itself to recognize these digits. So I mean, think of the possibilities, right? It knows to identify these. So next we can tell it, we can give it our own data. We've shown it 0 to 9 because of MNIST. We can create our own training set, and we can show it that, and it can learn from those data sets. And then once it can identify and learn to do things, we can tell it what to do based on what it's learned. So the possibilities, amazing. So yeah, thank you so much for watching. Thank you so much for dealing with my lack of bracket putting for the print statement. I'm going to edit that out anyway. I'm not going to keep you on here for 20 minutes. But thank you so much for watching. Subscribe for more. Like, share, subscribe. What else do you say, bro? If you have any doubts with the code, comments. Yeah, thank you so much for watching. I said thank you so much for watching 3 times. Get lost. Subscribe. That also I said. Bye.